I'm Evan Wesley from the University of Kentucky, majoring in natural resources and environmental science.
And I'm Jacob Powell from the University of Georgia, majoring in environmental engineering.
And this summer, Jacob and I had the opportunity to come down to Homestead, Florida at the Tropical Research and Education Center and work on individual projects as a part of an NSF research experience for the undergraduates, or REU.
Our projects are both part of an ongoing collaboration among TREC, USGS, the South Florida Water Management District, and Miami-Dade County since May of 2010 at a site called Snapper Creek Canal in Miami-Dade County. The overall goal of both of our projects is to try and find more simplistic and cost-effective means for measuring evapotranspiration, or ET.
ET is generally estimated using weather-based equations, but for the sake of my project, we want to be able to estimate ET as a function of photosynthetic active radiation, or PAR. Now you might be wondering, what is PAR? PAR is the wavelength range of visible light from 400 to 700 nanometers that photosynthetic organisms, much like this grass, this tree, and those groves, use in the process of photosynthesis. Now, PAR has been speculated to be a more viable way to effectively quantify evapotranspiration.
My research project is based on another promising option for estimating ET, the Bowen Ratio, which is a ratio of sensible heat flux over latent heat flux. The Bowen Ratio can be plugged into an energy balance equation, where it will then, in essence, solve for evapotranspiration.
In terms of radiation, whether it be UV or infrared, PAR has the biggest impact and is the biggest driver of evapotranspiration. Now, knowing this relationship, we want to use PAR and any other variables we see necessary to accurately estimate actual evapotranspiration from eddy covariance data. Now, I say necessary variables because at the end of the day, we want to be able to develop an equation with the least amount of components that still yields accurate ET results.
In the field, the Bowen ratio is calculated by an equation where a ratio of vertical gradients of air temperature and vapor pressure are multiplied by a unique psychrometric constant. A device called the Bowen ratio system is typically used to measure the gradients above the vegetative surface at two different heights. The energy balance for the ground surface can be altered to solve for ET as a function of net radiation, solar heat flux, and the Bowen ratio by substitution. This is important because by using this equation, we bypass the complicated and difficult process of calculating the latent heat flux, which is in turn used to calculate ET.
Now we're here at Snapper Creek, where our overall objective is to estimate ET in the cheapest and simplest way possible. What you're looking at is the eddy covariance system, which is far from cheap and far from simple. That's why the University of Florida has taken it upon themselves to set up a variety of instrumentation here at Snapper Creek. But for the sake of my project, we QA'd the data and selected 3 specific variables that we thought would be good components in developing an equation to estimate ET. That first variable is temperature, measured by this temperature probe right in front of me. The second is volumetric water content, measured by a soil moisture sensor deep within this ground. And third is PAR, of course, measured by this pyranometer right next to me. These 3 variables were accurate, but by using a singular linear regression model, we were able to create an estimation equation with PAR standing alone and accurately estimating eddy covariance data. Now let me put this in simpler terms. Out of all this instrumentation here at Snapper Creek, its sole purpose is to estimate evapotranspiration, whether it be a tensiometer, a rain bucket, a radiometer, or a temperature probe. They have one job, and it's to estimate ET. But through this estimation equation, as a sole function of PAR, we can accurately estimate eddy covariance ET through one instrument, and that's the pyranometer, the holy grail of ET estimation.
Out here at the Snapper Creek study site, we unfortunately do not have a Bowen ratio system which directly measures the Bowen ratio. So therefore, for my research this summer, I've had to try to come up with alternative methods for estimating the Bowen ratio, using, for example, all of these sensors that are located right here from UF, and also from the USGS eddy covariance system, which is right here. To estimate the Bowen ratio, various techniques have been examined. First of all, trying to use all of this available data here at the UF site to recreate the Bowen ratio vertical flux equation. Second of all, I used all of this available data to try and use curve fitting software to come up with a Bowen ratio model that would predict the ratio. And third, I used the eddy covariance system data to try and estimate the Bowen ratio on a monthly basis, to use the Bowen ratio energy balance equation to estimate ET.
This is the developed equation created by singular linear regression as a sole function of PAR. This equation is a better estimator of actual ET than the Turk equation with the crop coefficient, even though the Turk equation is known to be one of the simplest and most accurate methods to estimate ET. Let's compare the PAR and Turk equations to our EC data visually. This graph illustrates the close relationship among the PAR equation, the Turk equation, and our actual EC-ET values. However, do not let this graph fool you. Turk may seem to be just as accurate as my developed equation, but Turk has an average daily difference of ET values of 0.39 millimeters per day compared to the PAR equation's 0.2 millimeters per day. Also, Turk overestimates a 5-month sum of ET by 44 millimeters a day, whereas my PAR equation overestimates the same 5-month sum of ET by 0.3 millimeters per day.
In the end, for my project, after analyzing and testing several equations and models, I've come to the conclusion that using the Bowen Ratio monthly average value is the most effective and accurate means of calculating ET in relation to the eddy covariance value of ET. For future studies, I would advise the continuous calculation of the monthly average Bowen Ratio values by the eddy covariance data to ensure that from year to year the monthly average Bowen ratios are similar.
In conclusion, PAR is a cheaper and more feasible way to accurately estimate actual evapotranspiration. Requiring only one instrument in the field and one input variable in its equation, PAR has trailblazed a new path for the future of evapotranspiration estimation. This summer in Homestead at the Tropical Research and Education Center was definitely a summer of first. I swam with my first sea turtle, I went parasailing for the first time, I went to South Beach for the first time, I had a 46-year-old Nicaraguan roommate for the, second time. Just all in all, the experience from the climate to the food, to the plants and the trees and everything in between. It was so unique, and the people were so great. It was a summer of a lifetime. It was great.
Now, on top of our awesome experience that we've had here at Trek this summer, we also got the great opportunity to meet up with all of our fellow REU participants from Gainesville and Lake Alfred this summer and travel around the state of Florida in a van for a week and hit up a bunch of different locations around Florida dealing with water resources, different facilities, water treatment plants and tree farms, and just get a better idea of how water is utilized in the state. And that was just a great experience to see all that stuff and also just to bond with all of the fellow REU participants and round out the whole experience. Yeah, we had so many good memories this summer, dude. Remember all the ping pong battles we had in the Thunderdome?
Oh, Thunderdome was so good. Do you remember going to Penny Camp and kayaking through the mangroves?
Kayaking in the mangroves, that was sweet, dude.
That was balling.
And the several visits to South Beach this summer, pretty much every weekend. And
the Kardashian store?
Going to Dash.
Yeah, remember we took a trip to Sonar's court, basketball, played some basketball every day, dude. Daily battles.
Daily battles, domination at the basketball court.
Yeah. What else we do?
Miami Marlins baseball game. That was sweet.
Sweet, man. Yeah, all the beaches we went to.
Yeah, I don't know.
Action.